Okay.
Okay.
Hey, hi.
Okay.
This is
This is
Vishal,
Vishal,
EPH
EPH
third year
third year
student.
student.
Today I'm
Today
going
I'm
to
going to
present
present
my
my
CWS
CWS
project
project
under the
under the
course of
course of
Fundamentals of
Fundamentals of
AI/ML.
AI/ML.
My
My
project
project
title
title
is
is
Flight
Flight
Delay
Delay
Prediction
Prediction
and
and
Analysis
Analysis
using
using
Artificial
Artificial
Intelligence
Intelligence
and
and
Machine
Machine
Learning.
Learning.
Okay.
Okay.
The
The
first,
first,
now
now
let's
let's
look at
look
the
at the
objective.
objective.
The
The
first goal
first goal
was to
was to
build
build
a
a
predictive
predictive
model
model
that
that
can
can
classify
classify
whether
whether
a
a
flight
flight
will
will
be
be
delayed,
delayed,
yes
yes
or
or
no.
no.
The
The
second goal
second goal
was to
was to
estimate the
estimate the
delayed
delayed
duration in
duration in
minutes.
minutes.
Apart
Apart
from
from
that,
that,
I
I
also
also
implemented
implemented
an
an
operational
operational
adjustability
adjustability
index,
index,
which
which
helps
helps
prioritize
prioritize
controllable
controllable
delay
delay
costs.
costs.
For
For
example,
example,
issues
issues
related to
related to
crew,
crew,
aircraft,
aircraft,
and
and
turnover,
turnover,
various
various
uncontrollable
uncontrollable
ones
ones
like a
like a
bad
bad
weather.
weather.
Another
Another
objective
objective
was
was
to
to
apply a
apply a
sharp,
sharp,
shapely
shapely
additive
additive
explanation,
explanation,
which
which
is
is
a
a
tool
tool
that
that
helps
helps
us
us
understand
understand
why
why
the
the
AI
AI
model
model
makes
makes
a
a
certain
certain
prediction.
prediction.
And
And
finally,
finally,
the
the
goal
goal
was
was
to
to
measure
measure
the
the
business
business
impact,
impact,
how
how
this
this
prediction
prediction
actually
actually
helps
helps
airlines
airlines
reduce
reduce
operation
operation
inefficiency
inefficiency
and
and
improve
improve
customer
customer
satisfaction.
satisfaction.
So
So
basically, this
basically, this
project
project
connects
connect
data
data
science,
science,
AI
AI
modeling,
modeling,
and
and
business
business
understanding.
understanding.
Okay.
Okay.
Data
Data
overview
overview
and
and
EDA
EDA
insight.
insight.
The
The
dataset I
dataset I
used
used
contains
contains
a
a
monthly
monthly
flight
flight
records,
records,
including
including
flight
flight
count,
count,
delay
delay
flight,
flight,
and
and
cause
cause
of
of
delay.
delay.
Now,
Now,
before
before
building
building
any
any
model,
model,
I
I
did
did
exploratory
exploratory
data
data
analytics
analytics
to
to
understand
understand
what the
what the
data
data
looks
looks
like.
like.
From this
From this
analysis,
analysis,
a
a
few
few
interesting
interesting
insights
insights
came
came
out.
out.
Seasonal
Seasonal
trends.
trends.
Basically,
Basically,
delay
delay
peak
peak
during
during
summer
summer
months,
months,
June
June
to
to
August.
August.
That
That
shows
shows
that
that
delay
delay
behavior
behavior
follows
follows
a
a
predictable
predictable
yearly
yearly
pattern,
pattern,
which
which
means
means
airlines
airlines
can
can
plan
plan
resorts
resorts
like
like
in
in
advance.
advance.
To
To
delay
delay
cause,
calls,
late
late
aircraft
aircraft
and
and
carrier
carrier
delay
delay
are the
are the
most
most
common.
common.
That
That
means
means
most
most
delay
delay
are
are
related
related
to
to
operational
operational
inefficiency
efficiency
rather
rather
than the
than the
external
external
cause
cause
like
like
weather.
weather.
Systemic
Systemic
relationships.
relationships.
Large
Large
airports
airports
have
have
stronger
stronger
correlation
correlation
with
with
multiple
multiple
delay
delay
types,
types,
showing
showing
that
that
congestion
congestion
is a
is a
real
real
operation
operational
challenge.
challenge.
Carrier
Carrier
specific
specific
behavior.
behavior.
Different
Different
airlines
airlines
perform
perform
differently,
differently,
which
which
highlights
highlights
that
that
each
each
carrier
carrier
needs
needs
its
its
own
own
customized
customized
delay
delay
reduction
reduction
strategy.
strategy.
So,
So,
this
this
part
part
of
of
this
this
analysis
analysis
shows
shows
that
that
delay
delay
are
are
not
not
random.
random.
They
They
have
have
clear
clear
pattern
pattern
depending on
depending on
season,
season,
airport
airport
size,
size,
and
and
carrier.
carrier.
If you
If you
see
see
this
this
graph
graph
is
is
shows a
shows a
count
count
of
of
delay
delay
by
by
main
main
delay
delay
reason
reason
for
for
AB
AB
airport.
airport.
Average
Average
arrival
arrival
delay
delay
by
by
month.
month.
Here is
Here
the
is the
reason
reason
of the
of the
delay
delay
is the
is the
number of
number
the
of the
delay
delay
counts.
counts.
Average
Average
delay
delay
minutes
minutes
in
in
months.
months.
Yeah.
Yeah.
Data
Data
preparation
preparation
and
and
future
future
engineering.
engineering.
After
After
understanding the
understanding the
data,
data,
the
the
next
next
step
step
was
was
data
data
preparation and
preparation and
featuring
featuring
engineering.
engineering.
Basically,
Basically,
this
this
step
step
means
means
cleaning the
cleaning the
data
data
and
and
creating
creating
new
new
features
features
that
that
will
will
help
help
the
the
AI
AI
model
model
learn
learn
better.
better.
In
In
my
my
code,
code,
I
I
did the
did the
following:
following.
removed the
Remove the
duplicate
duplicate
and
and
handle the
handle the
missing
missing
values,
values
and
and
using
using
the
the
pandas
pandas
commands
commands
like
like
okay,
okay,
I
I
cap
cap
out
out
I capped
cap
out
out
like
like
at
at
the
the
94th
94th
percentile to
percentile to
make
make
sure
sure
external
external
values
values
don't
don't
mislead
mislead
the
the
model.
model.
Then I
Then I
understand
understand
and
and
okay.
okay.
Then
Then
I
I
standardize
standardize
the
the
categorical
categorical
feature
feature
like
like
airline
airline
and
and
airport
airport
code
code
to
to
make
make
them
them
consistent.
consistent.
For
For
future
future
engineering,
engineering,
I
I
added
added
few
few
columns
columns
like
like
delay
delay
ratio,
ratio,
total
total
delayed
delayed
flight
flight
divided by
divided by
total
total
flight.
flight.
Mainly
Mainly
delay
delay
reason,
reason.
the
The
category
category
causing
causing
the
the
largest
largest
delay. Applied frequency encoding for categorical column like carrier and aircraft Airport. I grouped month into four seasons: winter, spring, and summer, falls. Finally, I created two target variables: classification model and the regression model. So, what this means is basic by carefully preparing and structuring the data, I made it ready for the both type of machine learning models. Predictive model, predictive model performance and selections. One of the data was ready. I built two types of machine learning models. Basically, the idea was one model should tell whether a flight will be delayed, and the another should tell how much delay we can expect. For the classification task, I used the CAT boost classifier, and for the regression task, I use the gradient boosting regression. Let's talk about each one of in detail. CAT boost classifier. The CAT boost classifier is based on the gradient boosting technique, which means it builds a series of a small decision tree, each one learning from the mistake of the previous one. The reason I choose CatBoost is because my dataset has many categories column like airline, code, airport name, and CatBoost can handle them automatically into a manual encoding. After training, I got a accuracy of 86.7% and the F1 score of 81.7% using a 20 minutes delay threshold. Basically, that means the model correctly classifies about the 87 out of 100 flights. The top feature influencing the predictive prediction were late aircraft delay, season, and carrier. So, this model helps airline forecast which, which flight are at risk of delay before departure. Now, let's talk about the another model, re- gradient boosting regression. For prediction, the actually delay duration in minutes, I use the gradient boosting regression. This model also works by combining many decision trees, but instead of predicting category, it predicts the continuous values. The regression achieved the lowest MAE, mean absolute error, and root mean square error, which means made to smallest mistake among all the tested tools. Basically, what this shows is the gradient boosting regression capture the complex relation in the data very well, such how seasonal carrier type and delay reasons interact together. These two models, cat boost and gradient boosting, from the predictive core of this project. Next, sharp analysis. Now this slide shows the sharp analysis stands for Shapley additive extension. Basically, when when we build AI model, it can make a very accurate prediction, but we often don't know why it made them. Sharp helps explain that why, showing how much each feature contributes to specific prediction. For this sharp summary, a plot we can see that late aircraft delay is the most important factor, followed by season and carrier type. So, what this means is if the late aircraft delay values is a high, the model will almost always predict a high overall delay. Basically, Sharp gives a interpretable interpretability. It tells airline why a certain flight predicts to be delayed. So, overall, Sharp makes the air transparent and trustworthy, which is a very important real world decision making. Business impact analysis. Now, Let's look at what all this analysis actually mean for airline business impacts. Seasonal trends. Summer months shows 40 to 60% high delay rate. That basically means airline should be plan extra resources backup crew in the season. Late aircraft delays. This cause cascading disruption. One delay plan often lead to multiple downstream delays. Carrier performance. Perform different airline performs differently. So improvement strategies need to be carrier specific. Airport capacity. Congested airport shows more delay meaning delay delays, meaning infrastructure upgrades can make a big difference. Weather delays even though weather can't be controlled. It follows a predictable season trend. So airline can plan a contingency operation. Crew and maintenance, these are controllable and offer immediate opportunities to improve the efficiency. Basically, what this shows is the AI based analysis doesn't predict, it gives action, actionable insight that can be directly helpful business operation. Recommendation. Recommendation for delay reduction and operational excellence. Based on all this finding, here are my recommendations for airlines. Implementation predictive maintenance during low season to minimize the disruption later. Optimizing crew scheduling during summer peak to reduce carrier related delays. Develop weather contingency protocols for better reliances. Deploy real time predictive models for dynamic real management. Improve aircraft turn around the process at high delay airports. Use historical delay pattern for smarter scheduling. Invest in predictive analytic infrastructure for term long term again. Design airline specific delay mitigations and strategies improved. Improvement passenger communication to maintain a satisfaction. So basically, what this means is that by combining AI prediction with good management strategies, airline can actually prevent delays before they happen. Thank you. This is my code which I have built for classifications. And just a second, the code is running. Yeah, the code is run. This is a classification model that I used for the gradient boosting and the cat boost regression. And this is my another code. For sharp value average impact on model output and magnitude. This code. This code shows the count of the delay by main delay reason for the AV airport, main delay reason and the number of delays. Yeah, this is my classifications. This is my self analysis. Yeah, thank you.